Okay, hi. Here we go with lecture number 5 of psychopharmacology. I'm going to be using this recording to kind of play catch up. I realized that the last class that we've been talking about a number of different things and haven't always talked about exactly what's on the syllabus, which is fine. I'd rather talk about things that are interesting and noteworthy as opposed to necessarily having to follow a certain script. But there were a few things I wanted to catch up on uh, that didn't always fit, um, that there wasn't always room for during the class meetings, and haven't always had a definite place in the video lectures. So what I wanted to start off tonight with, and by the way, what you will notice is I'm going to stop and start a bit here because I'm going to pull up different slides, different things to talk about. But where I wanted to start tonight, or for this video lecture, was on uh, was I'm going to share on the screen here a video called it's from a lecture called um, how neurotransmitters work. And I'm specifically going to cover some of the basics of neurosynaptic transmitter, basically how neurotransmitters work. Now, what we have talked about so far is at the very base of uh, at the very base of how psychiatric medications work is this whole idea of different chemicals going through neurotransmitters: dopamine, serotonin, norepinephrine, GABA. Um, but we haven't. I think it was useful to go through some basics here about how neurotransmitters work. And um, so here's what happened. So this is just a basic of how neurotransmitters work. Um, so what ends up happening is what is called an action potential. Um, and what happens is, um, so what you end up happening, um, this is the neuron itself, and these are the axon terminals. So this is the neuron. The neuron actually has every neuron has three parts, and it's called a neuron, but actually in actuality, the neuron is just this sort of the head part of it. Then there's the axon, which is sort of where the so something happens in the neuron, chemicals are released, which is called the action potential, and then the chemical is sent through the chemical message is sent through the axon and the axon terminals. This involves the release of the neurotransmitters. So the neurotransmitters are the chemicals, the chemicals that are impacted by psychiatric medications. And the chemicals have their impact on the neurons and what the neurons do. So basically, what happens is something happens to the neuron, it is stimulated. This is this word up here: excitatory stimulation of the neuron. Action potential, meaning uh, the neuron sends a chemical message uh, through the axon, and the axon is told to release certain neurotransmitters through the axon terminals. And it all goes one direction. And so you can sort of see that you can sort of picture here what happens when we've been talking about the release of serotonin, uh, norepinephrine, dopamine, you can see what happens. This is where they're released at. But then what happens is this excitatory stimulation, what happens is this, if you picture that the brain works on billions, if not trillions, of these specific types of cells called neurons. If you picture what happens here, a good and I keep messing up here. Sorry. If you think about what happens here, you can picture that this is the chemicals are being released from here. The neurotransmitters are being released from here. So serotonin, norepinephrine, dopamine are released from here. But if you picture the way the brain is set up with these neurons, there's an exact one of the, or there's another neuron sort of right in front of this, the same way that there's another neuron right behind it. So what happens is the serotonin, let's say, shot out of here, but at the same time, there's other chemicals coming from behind this thing that are shot into it. So this is shooting chemicals into the next neuron while also accepting neurotransmitters from the one behind it. So there's a whole bunch of them, and that's where this whole idea of serotonin, let's say serotonin reuptake inhibitor comes from, or selective serotonin reuptake inhibitor. What happens is, while at the same time serotonin is shot out of here, there is not as much serotonin being brought back in to the neuron. So the neuron, the serotonin that's not stored in the neuron is kind of shooting past the neuron. So there's serotonin coming out here, but then there's also serotonin sort of continuing to pass by this neuron. And that's what leads to the increase in serotonin when you have less serotonin coming into this neuron. Okay, and then just one thing here, and by the way, I always called this body, this is a mistake, but let me just for technicality, I always call this the neuron, and in actuality, the whole thing is the neuron. One of the reasons I do this, the technical name for this is up here, neuron. So it's basically neuron with the E on the end of it. So this whole thing is called the neuron. This part of it, the part that the serotonin or neurodopamine or whatever transmitter is coming into it, is called the neuron. I just always call it the neuron, but this is the neuron. Technically, is this whole thing. This is the neuron. This is the axon where the action potential, the chemical message, the message about the chemicals is sent. And then these are the axon terminals. A couple things about neurons. The neurons do not physically touch each other. And by the way, I think this is wrong. I would say that this is the neurons do not physically touch because no part of the neuron touches each other. Notice this is the picture of it here. Notice what happens is, if you look at two neurons, they look like they're physically touching, but there's not. If you look real close, and that's what they're picturing here, there's a gap. There's a gap in this picture right here. And then this is what you have here. The gap is called the synaptic cleft. So you've got the axon terminal, and there's two terms for it. This is the presynaptic neuron. So the one in the back is called the presynaptic neuron, and the one in the front is called the postsynaptic neurons. And so a couple things can happen. It can either be when the chemical message comes across, so it's basically passing messages. This one passes a message to the next one, passes to the next one. when it passes from this neuron to the next one, the message could be either increases activity, which means excites, it decreases, which means inhibit, or causes something else to happen as far as a biochemical process. And here's a little bit more of a little bit more detail about what happens when the neurons are being impacted. So action potential. An action potential is basically a message sent through the neuron to do something with the neurotransmitter. So the action potential reaches. This is one reaches is here, reaches the presynaptic neuron, and then what ends up happening is the thing that really gets the message flowing, which causes the message to flow, the action potential message to flow, is calcium. So calcium is a big part as far as how the neurons communicate within each other. So there's an influx of calcium ions, and then that releases the message, whether it's a message to excite or inhibit the action potential. And then the neurotransmitters cross over, so it either so neurotransmitters are stored up here. And so as the calcium ions come in, it causes the neurotransmitters to be released, and then when they are released, they attach to specific receptors on the postsynapse. So the calcium ions come in, they cause certain transmitters to be released, and then so they cross the synaptic cleft here, which is that gap, and then one of three things happen: either the as the neurons go across, either the neuron will open or close as a way of letting in or inhibiting the increase of the neurotransmitter, or it'll either cause some sort of other biochemical process. So, but the big thing here is when we talk about, so notice what happens here. The calcium ions come in and the neurotransmitters are released. It's really here where this whole idea of whether, it's really here over the synaptic cleft where and here with the receptors, where they get the message of whether it is supposed to release or inhibit, or accept or inhibit the acceptance of the neurotransmitter. So notice what the message that comes to the receptors here is to not take in as many serotonin or dopamine or whatever neurotransmitter. If these are closed up by the message that's sent from this neuron, then they kind of get tossed out. So they kind of get released. But if they're not accepted, then they just sort of go off into the rest of the brain, which increases the amount of neurotransmitter that's in the brain. And this is just the neurochemistry part of it. So I wanted to just show you, like I said, I wanted to just show you what the neurotransmitters look like. I'll be honest with you, when I was in graduate school, we took a course on psychopharmacology, and the professor spent a great deal of time talking about how neurotransmitters work And I never found it particularly useful. Um, so I didn't want to spend that much time talking about the actual process of how neurotransmitters work and how neurons work. It's interesting, but as far as its application in the field of psychology, it's not particularly useful because not a whole lot we can do with it. Um, so I wanted to just cover the basics. There you go. We can certainly talk more about how neurons work if it becomes more relevant for some of the medications that we're talking on. For right now, that's the basics. And I wanted to move on to a different topic,